Welcome to today's lecture. Today we are going to continue from where we had left in the previous lecture. Today we are going to talk about the types of machines, and also we'll talk about the various types of foundations. In general, the machines can be classified based on the operating frequency. Then they can be classified based on the mechanism of operation. They can also be classified based on the nature of forces generated by the machine. They can also be classified on the basis of the geometry of the foundation supporting them. So let us see all these classifications. The first is based on operating frequency. The code IS 2974 part 3 classifies the machines into three categories: low frequency, medium frequency and high frequency based on the operating frequencies. Now, what are the cutoff frequencies between these ranges? So let's see. So low frequency machines are those machines which operate at frequencies less than 25 Hz. That is up to 1500 RPM. Above 25 Hz and less than or equal to 50 Hz, the machines, they are classified as medium frequency machines. So 50 Hz basically corresponds to an RPM of 3000. And finally, the machines which operate at frequencies greater than 50 Hz or 3000 RPM, they are called as high frequency machines. Now let's see some of the examples of these category of machines. Compressors, pumps, etc., they are low frequency machines, and here typically the operating frequency is less than the natural frequency of the foundation soil system. Usually such machines, they are provided with block type foundation directly resting on soil, so they are generally sufficient. examples of the medium frequency machines are motors. Usually in such machines, the operating frequency is of the same order and range as the natural frequency of the soil foundation system, and sometimes these kind of machines, they face problem of the resonance, and usually they are provided with springs or similar mechanisms so that their natural frequency of the foundation soil system is reduced. Now, some of the examples of the high frequency machines are turbo generators and IC engines operating at high frequencies. So in these machines, typically the natural frequency is much greater than the operating frequency of the machine. So these machines, they require frame type foundations. Their operating frequencies are generally higher than the natural frequency of the foundation soil system. Hence, these machines, they face momentary resonance during switch on and switch off process. The next classification of machines is based on the operating mechanism of the machine. In this category, we may have reciprocating machines. For example, the internal combustion engines, so they have piston mechanism, or we can have rotating type machines. For example, motors and turbines, or we can have a combined type machine where both the reciprocating and rotating components are there. Such machines, they usually involve conversion of one type of motion into other, that is rotating motion into reciprocating type or vice versa. The next classification of machines is based on the nature of forces generated. So in this classification, we can classify the machines which generate periodic forces. For example, repetitive kind of force signal, it could be sinusoidal like this, or the waveform could be different, also not exactly sinusoidal. Examples include compressors, air handling units in buildings having central air conditioning systems, now the other type of machines are those which impart or generate forces which are not periodic. For example, they may generate impact type forces. So impact type forces are something like this if we plot their variation with respect to time. So we may have these kind of signals, so they are not periodic but they are like sudden impact forces. Some of the machines in this category are Universal Testing Machine or UTM, forge hammers. They generate these kind of forces. The next classification of machines is based on the geometry of the foundation system under the machine. So here we are bringing foundation into the picture. So there could be different types of foundations depending on the type of the machine, the type of the anchorage system. So the simplest type of foundation is a block type of foundation. So here essentially there is a block of reinforced concrete which supports the machine at the top. The depth of the block is decided by the geotechnical engineer and recommended. Sometimes if the loading is not very high, shallow foundations are also recommended, and sometimes they are recommended on compacted soils. So these type of foundations are very common for low frequency machines. Because these machines, they do not generate very high forces. And these are also provided for low to medium frequency or low to medium capacity pumps and compressors. The other type of the foundation system is box type foundation. Essentially, the box type of foundation is adopted where, because of the large size of the machine, constructing a very large solid block is likely to be uneconomical. So here essentially box type foundation is constructed, and this process is concrete and makes it economical. So here there is a pocket in the interior of the block, and the machine is anchored at the top using anchor bolts. So anchor bolts are left at the top. They are cast together with concrete. The machines are brought and they are fitted. Sometimes the cavity is filled with low density filler materials. As stated before, Box type foundation is usually suitable for machines which are needing large foundations in plan. The next type of foundation is wall type foundation. Essentially, this kind of foundation consists of two or more parallel walls, quite long in dimensions. So cross section wise we may find them like this, that there is a base raft, and from the base raft, which is concrete, there stem up two monolithic walls. Walls could be more also depending on the machine, and the machine is then mounted on these walls using anchor bolts. Sometimes the space between the walls is not filled with soil and is left open for inspection purposes. So typically these kind of foundations, they are suitable for those machines which are very long in horizontal direction. Some of the examples of such machines are horizontal boilers, so generally the anchor bolts are provided at the two far ends of the machine. Now besides the block type, box type and wall type, we have frame type of foundations. So essentially such kind of foundations are full-fledged frame in themselves. They have very large dimensions of beams and columns, and there is roof slab also, and the columns, they stem out from a very thick raft at the base. So essentially they could be of very large size, and they are like a reinforced concrete 3D frame type structure. So we can find here all the components of a 3D space frame, like RC slab, beams, columns, and finally a very thick raft kind of foundation. Finally, the machine is anchored at the top of the deck slab, and the anchors are usually stemming out of the beams. So these kind of foundations are provided for very high speed rotating machines like turbo generators. Most of the thermal power plants in our country, they have such kind of machine foundations. They sometimes could be very tall and big in size, just like a multi-story three-dimensional structure. So here are some of the examples. This turbo generator foundation is for a thermal plant, and this picture is sourced from SERC Chennai website. Now you can appreciate how massive and large size these foundations are. Similarly, here we are showing top view of another frame type foundation. So here the term foundation is being used for the entire structure, starting from the base raft to the top of the first floor, which could be very high. If you happen to visit any such foundation, you would get the feeling of a massive superstructure rather. So for our definition, any structure on which the machine is supported, we call it as machine foundation. And of course, from the structural engineering point of view, it will have its own foundation system and then the framing system stemming out of it. So thank you very much. If you have any questions, you can discuss them during our interaction in the MST.